Good morning everybody. In previous video we learned congruency and symmetry. Congruency, symmetry, line symmetry, point symmetry. So today class 9th chapter, area of a plane figures. Area of a plane figures. Exercise 9.1. First question, divided the given shapes in instructed. Here given some shapes. Here first one into 3 rectangles. Here divided. These diagram we divided into 3 rectangles. Now here given the diagram. So now this diagram is divided into 3 rectangles. So we draw the lines here. We draw the here one line. Next, here also we draw one line. Now here this diagram is divided to 3 rectangles. So we write the names A, B, C, D, E, F, G, H, I, J. So now here we write the parts name. Here rectangle. Here rectangle. Here A, B, C, D. A, B, C, D. Next rectangle. Here C, E, F, G. C, F, E, F, G. C, E, F, G. Next rectangle F, H, I, J. F, H, I, J. So these are the 3 rectangles. Now next one is the here into 3 rectangles. Here this is the U-shaped diagram. So this diagram also we divided into 3 rectangles. So here we join these 2 points. Here also join these 2 points. Now here this one is the one rectangle. This one is one. Here this is the one. So here 3 rectangles. We write the points here A, B, C, D, E, F, G, H, J, I. Rectangle A, B, C, D. Rectangle E, F, G, H. Here rectangle C, H, I, J. So here these 3 are the rectangles. Next third one. Here one diagram is given. This one into 2 trapeziums. So now we draw the middle one line. Now here upside one trapezium and downside one trapezium. So we write names A, B, C, D, E, F. Now here we write the trapezium. A, B, E, F. A, B, E, F. Next trapezium B, C, D, E. B, C, D, E. These 2 are the trapeziums. Next diagram here. Fourth one is the 2 triangles and a rectangle. Here 2 triangles. Now here draw the lines here. Here we draw the 2 lines. So now here these 2 are the 2 triangles. Next middle one is the rectangle. So now here we write the names A, B, C, D, E, F. This is the diagram. Now we write here triangles. Triangle A, B, C. Next triangle D, E, F. Next rectangle. Here rectangle is equal to A, C, D, F. D, F. Here into 3 triangles. Here asking 3 triangles. So we draw the lines here. Here to here. Next here to here. Write the A, B, C, D, E. Here triangle A, B, E. A, B, E. Triangle B, D, E. B, D, E. Next B, C, D. A triangle B, C, D. These are the three triangles in this diagram. So now your first bit is completed. Next, second question, find the area enclosed by each of the following figures. Here three diagrams are there. So measurements also here given. We find the area of this diagram. Now here pentagon ABCDE pentagon. Here AE ED DC AC. Here 4 centimeters means here also 4 centimeters, 4 centimeters. Here also 4 centimeters. Now here to here 6. Here to here means 6 here. We draw the perpendicular line on AC to B. Here this is the perpendicular line. So now here to D to C is 4 centimeters means here 6 minus 4. Here this perpendicular line is 2 centimeters. 2 centimeters. F to write F. Here F to B is the 2 centimeters. Now here we find the area of these two diagrams, triangle ABC and square ACDE. We find these two areas and add these two areas. So that is the complete pentagon area. Now here we write the area of a pentagon. Here area of a pentagon ABCDE is equal to area of square. Here area of a square. Here ACDE is a square. ACDE plus area of a triangle ABC. Triangle ABC. So now here find these two areas. Here area of a square. Square is the L into B. Here side into side. AE into ED. AE into ED is the area. Next area of a triangle. Here 1 by 2 height into base. Here 1 by 2. Here AC is the base into BF is the height. Now here substitute these values. Here AE is the 4 centimeters. ED also 4 centimeters plus 1 by 2 into AC. Here AC is a 4 centimeters and BF is equal to, already we know that 2 centimeters. BF is equal to, here AC equal to 4 into BF is equal to 2 centimeters. Here we write the BF is equal to here total distance 6. Total distance 6 minus here 4 equal to 2 centimeter. 2 centimeters is a BF. BF is a 2 centimeters. Now we write here BF equal to 2 centimeters. 4 4 is 16 minus 2 get cancelled minus 4. Here 12 square centimeters is the area units. So this is the second one answer. Second question. Next diagram is this one. So now here we find the given diagram. We find the area of this diagram. This is the given diagram. We find that this diagram complete total area. So now here we write this diagram is divided into two parts. Here first, here we draw here one line, join E and C points. So now here A to B is 18 centimeters. E to C also 18 centimeters. So now here E to A 18 centimeters. C to B 18. Here to here is the 8 centimeters. 8 centimeters means these two 8. This height is 8 centimeters because here 8 centimeters. So this complete height is equal to 8 centimeters. So now here E to D 7 centimeters. Now first we find the area of a square. This square area we find after. Next area of a trapezium. We find the ED EC trapezium area. So this complete area is equal to sum of these two parts area. So first we write the area of a figure ABCDEF is equal to here area of a square. Area of a square ABCF plus area of a trapezium. area of a trapezium. Area of a trapezium CDEF. So now here first we find the area of a square. Area of a square, here AB into BC. Here AB into BC, area of a ABCF. Here AB into BC plus here area of a trapezium. Here trapezium formula is the 1/2 into here CG. Here CG means here height. CG into so now here sum of parallel sides EC plus ED. ED plus FC or CF. So now here we write the values. AB is equal to 18 centimeters into BC equal to 18 centimeters plus 1/2 CG means here height 8 centimeters into 8 plus ED is equal to here ED is 7 centimeters plus CF equal to here 18 centimeters. 2 ones are 2 4s are here cancel. 18 into 18 equal to 324 plus here 4 into 7 plus 18 25. Now here 324 plus 4 into 25 equal to 100. So that is equal to, we write here 324 plus 100, 424 is a area. Here centimeter square is the unit. This is the complete area of this figure. Here sum of these two diagrams, here trapezium and square, sum of these two areas is equal to complete this figure area. 422 centimeter square is the total figure area. Next third one is this is the third one diagram. So now here this complete diagram we divided into here two parts. We draw a line A to D. Here this one is the AFED is a trapezium. Here height, here to here height is there. Here complete line is the 28. Here 28 minus 20 is the 8 is the height. Now here, so here this one is the 8 centimeters. Here 28 minus 20, here 8 centimeters. So now here B to C 15 centimeters, D to C is a 20, means here A to B also 20 centimeters. So next E to F 6 centimeters. Now here we find the complete this area. So here we write the area of a figure. Area of a figure. Here area of a figure ABCDEF. Here area of a figure ABCD equal to area of a rectangle ABCD. Area of a rectangle ABCD plus area of a trapezium. Area of a trapezium, here ADEF. So now here we find these two areas. Here first we find the first one area. Here what is the first one area? Here rectangle area is the A. Here we know the two sides BC and CD. So here DC equal 20, AB also 20 centimeters. So now here we write AB into BC is a area of a rectangle plus area of a trapezium. Trapezium is equal to 1/2 here height into here sum of these two parallel lines. Here height is the 8 centimeters. Here we write any name. Here we write the G to A is the height. GA into here parallel sides are EF plus AD are the parallel sides is equal to AB into BC. AB into BC is equal to here AB is equal to D to C 20. Here also 20 into BC. BC equal to 15 centimeters already given plus 1/2 into GA. GA is equal to 8 centimeters into EF. EF equal to 6. Here 6 plus AD means here BC 15 means here also 15 centimeters. So now here 15 here 20 into 15 300 plus 2 ones are 2 4s are 4 into 6 plus 15, 21. So now here 300 plus 4 into 21. 4 2s are 8, 4 1s are 4. 84 is equal to 384. Here 384 is the complete this diagram, this figure, complete this figure area. So here centimeter square is the units. So third one, complete we find the area. This is the complete third answer. Next third question, calculate the area of a quadrilateral ABCD when length of the diagonal AC equal 10 centimeters and the length of perpendiculars from B and D on AC B 5 centimeters and 6 centimeters respectively. Here AC is a diagonal, so diagonal to another 2 points D and B is perpendicular distance is given 5 centimeters and 6 centimeters. So now here we find the area of a quadrilateral. I am already draw one quadrilateral. Here naming ABCD. Here ABCD is a quadrilateral. When length of the diagonal AC 10 centimeters. AC, we draw the AC diagonal, that is the 10 centimeters. This one is the 10 centimeters. Next, from B and D on AC be 5 centimeters and 6 centimeters respectively. Perpendiculars from B and D. So now here we draw the perpendicular lines on B to AC, B point to AC, and next here B point to AC. Here perpendicular line D point to AC, and here perpendicular line B point to AC. So these two are the perpendicular lines, means here 90 degrees. Next, here B and D means here B is the 5 centimeters. B to, we write F and E. B to F is the 5 centimeters. E to D is the 6 centimeters. So this is the another perpendicular line. So now here first we find this complete area. Here this area, we know the heights of the diagonals. So direct formula is there. So we write that formula, area of a quadrilateral here ABCD. Here ABCD equal, direct we write the 1 by 2 D into H1 plus H2. H1 plus H2. Here D is the diagonal of AC. Next H1 and H2 are the perpendicular lines on D to diagonal. Next B to diagonal AC. These two are the H1 and H2. So now here we write here 1 by 2. Here D is the diagonal AC. Next H1 means here DE plus BF. So now here we write the values. AC is equal to 10 centimeters given in the question. Here AC equal 10 centimeters plus DE equal to 6 centimeters. BF equal to 5 centimeters. So now here 2 1s are 2 5s are 5 into 6 plus 5 11. 5 into 11 55. So 55 square centimeters is the units. Complete this area units. 55 square centimeters is the area of a quadrilateral ABCD. Next fourth question, diagram of the adjacent picture from as outer dimensions 28 centimeters 24 centimeters. Outer means this line. Here inner dimensions is 20 centimeters and 16 centimeters. Inner these dimensions. Find the area of shaded part of frame if width of each section is same. Here width of each section is same means here this distance is all sections are same. So here inner dimensions are given, outer dimensions are given. So now here we find the shaded area. Shaded area means this, we find this rectangle area, these two triangles area. Sum is equal to shaded part area. We find the shaded part area. This is the given diagram. So now here we find shaded area means this complete area is shaded area. So shaded part frame width of each section is same. So here each section width, here width is, now first we write the outer dimensions. Outer dimensions. Here outer dimensions equal to 28 is the length and breadth equal to 24 centimeters. 28 into 24 length and breadth. This is the outer. Now here we write the inner dimensions. inner dimensions, here inner dimensions equal to here 20 into 16, here length equal to 20 and width equal to 16. So now here we find the width. Here width equal to here width means this area, here this length. So now here this length equal to here, suppose here to here plus here to here equal to 24 minus 16. Suppose first we write the width. Here two widths are there. Here this one is two widths are there. So now here 2 into width is equal to here 24 minus 16. 24 minus 16 equal to 2 into width. Two widths are there. 2 into width is equal to here 24 minus 16 is 8. Here width equal to 8 by 2 equal to 4 centimeters. Now here width is the 4 centimeters. Here also 4 centimeters. Now here also 4 centimeters. Here also 4 centimeters. We write the names. Here A, B, C is a triangle. Next here D, E, F. Now here complete shaded region area. This is the shaded region. So this area equal to triangle area, rectangle area, this triangle area. Complete these three diagrams area. 2 triangles plus 1 rectangle area. So we write that area. Here area of a shaded region. Here area of a shaded region is equal to, here we write the, here first one is the area of BECD. BE rectangle BECD plus area of a triangle ABC plus area of a triangle DEF. These two triangles area. Now here rectangle area means here we know the length and breadth. So now here 28 into 4. Here CD into DE plus area of a ABC triangle, that equal to 1 by 2. Here AC into BC plus here 1 by 2 area of a DEF into DE. So now here substitute these values here. CD is equal to 28 into DE equal to 4 centimeters plus 1 by 2 here AC equal to 4 centimeters into BC also 4 centimeters plus 1 by 2 DF 4 DE also 4 centimeters. 2 ones are 2 twos are, here also 2 ones are 2 twos are. So now here 28 into 4. Here not 28, 20 here, because here BE is 20 means CD is 20, AF is 28. So we take CD means 20. So here 20 into 4, 80 plus 2 fourths are 8 plus 2 fourths are 8. Here 80 plus 6 96 here square centimeters is a shaded region area. Area of shaded region is equal to 96 square centimeters. So this is the fourth one answer. Fifth question, find area of each of the following fields. All dimensions are given are in meters. So here dimensions are given, that dimensions unit is meter. Here one figure is there, here one figure. So here we find the total area. So here separately we find these all areas and after add these all areas. So that is the complete diagram area. Here this is the given diagram. So now here first we find the ABCH. Here we find this area. So ABCH is a trapezium. So now here we find this area. Here AH is 80 centimeters, HC is 40 centimeters. So now here next BC is 30 centimeters. So now here we find the area. Here two parallel sides are there and height is there. So now here we find the ABCH trapezium area. Area of a trapezium ABCH. Here ABCH equal to, formula is the, here 1 by 2 h into a plus b is a trapezium area formula. Now we substitute the values. Here parallel lines are AB and HC. Height 80. So now here 1 by 2 into 80 into a plus b means here 30 plus 40. So now here we write here 2 ones are 2 40s are 40 into 70. That equal to, here we write here 2800 square meters. Here meters is the 2800 square meters is the area of a trapezium ABCH. Now next here we find the HCD, area of a triangle HCD. This is the, here 90 degrees is given. So here also 90 degrees. This is the right angle triangle. Here also 90 degrees. This is the right angle triangle. Here we know the base and height. Here 40 and 80. So we know the base and height. Now here we find the area of a triangle HCD. HCD is equal to 1 by 2 into HC into HD. So here base into height 1 by 2. Here HC is 40 into HD is 80. So 2 ones are 2 20s are. Now 20 into 80 equal to 1600 square meters is a area of a HCD is equal to 1600 square meters. Next we find the EID, area of a this triangle. Here 90 degrees means here also 90 degrees. This is the right angle triangle. We know the base and height. Same method we find the area of a triangle EID. EID is equal to, here EID is equal to 1 by 2 into EI into ID. Here EI is equal to, we write the 60. Here 60 is there. ID equal to 40. 60 into 40. Now 2 ones are 2 30s are. That equal to, here 30 into 40. 1200 square meters is a area of this triangle. Now next we find this trapezium area. Here we know the two parallel sides and height. So we find the trapezium area. Now here area of a trapezium FGIE, area of a FGIE is equal to, here 1 by 2 h into a plus b. Now here 1 by 2 h, here h is the 70, h height is the 70, parallel sides are 50 into 60. So now here 50 plus 60, here 1 by 2 into 70 into 50 plus 60, 110. So now here 2 ones are 2 5s are 10, 2 5s are. Here 70 into 55. Here 70 into 55 is 385. Here 0. 385 0 square meters is a trapezium FGIE area. Now last one is we find the triangle area. This is also, here two sides are there. AGF. This is the right angle triangle. So now here we find the this triangle area. So area of a triangle AGF. AGF is equal to, here 1 by 2 into AG into FG. AG into FG. 1 by 2 into AG. Here AG equal to 50 into 50. 50 into FG is equal to 50. Here 2 ones are 2 25s are. So now here 25 into 50. 25 into 5s are 125. Here 0 is there. We write 0 square meters. So now this is the area of a triangle AGF. Now here the area of a total field. So this complete field area is equal sum of these all areas. So area of the field area of the field is equal to here area of a trapezium ABCH plus area of a triangle HCD next plus area of a triangle EID plus area of a trapezium FGIF next plus area of a triangle AGF. Now add these all areas. Here area of a ABCH. Here first one is here ABCH. ABCH equal to here area is the 2800. Now write here 2800. Next area of a HCD. Area of a HCD is equal to 1600 plus 1600 plus area of a EID. Area of a EID 1200 plus 1200 plus area of a FGIF. Here this one is the FGIE is equal to 3850. So now next area of a AGF equal to 1250. Now add these all numbers. Add all numbers here. 10700 square meters is the unit. So this complete area of this complete field is equal to this one. This is the complete area of a field. This is the complete first one solution. Here one diagram is there. Now here we find the complete total area. Separate we find the each area. Here triangle, trapezium, triangle. Next triangle, trapezium, trapezium. Find out these all areas and add. This is the given diagram. So first we find the ABK is a right angle triangle. Here 90 degrees means here inner angle also 90 degrees. So we find first here ABK. Here one side is the 50, another one is the 30. So we find the triangle area. Area of a triangle ABK. ABK is equal to here 1 by 2 here AK into KB is equal to 1 by 2 here AK is equal to AK 50 base into height here 30 KB equal to 30. 2 ones are 2 25s are here 25 into 30 is equal to 750 square meters is the area of this triangle. Now we find the KBCI trapezium area. We find that trapezium area. Here area of a trapezium KBCI. Area of a trapezium KBCI. Here KBCI equal to 1 by 2 into H into A plus B. Here A comma B are the parallel sides. Here 1 by 2. Here H is the 60 centimeters. 60 meters. Here parallel sides are 40, 30. So 40 plus 30. 2 ones are 2 30s are 30 into 40 plus 30 70. Here 21 7 3s are 21 100 square meters is the area of a trapezium. Next we find this area. Here we find this trapezium area ICED. Area of a trapezium ICDE. So that equal to here 1 by 2 into H A plus B. That equal to here 1 by 2 into here H is equal to 80. Here H is equal to 80. Here parallel sides are ICED. Here 50. Here 40 plus 50. 40 plus 50. 2 ones are 2 40s are 40 into here 40 plus 50 90. So that equal to here 3600 square meters is the area of this trapezium. Now here we find this triangle area FHE. Here area of triangle FHE. Here this triangle, here this is the 1 by 2 into FH into HE. Here 1 by 2 FH equal to 20 into HE is equal to 40. So here 2 ones are 2 tens are 10 into 40. 10 into 40 means here 400 square meters is the area of this triangle. Now here we find this trapezium area. Here this trapezium area equal to, next here area of a trapezium, here area of a trapezium GJHF is equal to 1 by 2 into H into A plus B. So that equal to, here height is 80, parallel sides are 20 plus 40. These two are the parallel sides. So right here 1 by 2 into 80 plus parallel sides are 40 plus 20. So that equal to 2 ones are 2 40s are. So 40 into 60, that equal to here 2400 square meters is the area of this trapezium. Now we find this triangle area. Here area of a triangle AJG is equal to, here 1 by 2 AJ into JG. So this is the area. So now here 1 by 2 AJ is equal to, here A to J is 70 meters and J to G is equal to 40 meters. So now here 70 into 40 meters. So here 2 ones are 2 20s are. Here 70 into 20, 14,000 square meters. Now here we write the area of a complete field. Therefore area of the field, here area of the field equal to these complete all areas, area of triangle ABK plus area of trapezium KBCI plus area of a trapezium ICDE. Next plus area of a triangle FHE plus area of a trapezium GJHF plus area of a triangle AJG. So add these all areas. Now that equal to area of a ABK. Here first one is the ABK 750. Second one is the 2100. So here 750. Next KBCI is 2100 plus third one ICDE. Here ICDE area is equal to 3600 plus 3600 plus FHE equal to 400. Here we write 400 plus GJHF is equal to 2400 plus here AJG is equal to 1400. So add these numbers. So that equal to here 10650 square meters. This is the total field area. Here area of the field equal to 10650 is a total area. This is the second one, complete answer. Next, sixth question. The ratio of length of the parallel sides of the trapezium is 5:3 and the distance between them is 16 centimeters. If the area of the trapezium is 960 centimeters square, find the length of the parallel sides. Here parallel sides ratio is given. So use this ratio and find the parallel sides length. Here distance is 16 centimeters and trapezium area is 960 centimeters square. So here parallel sides of a trapezium is 5:3. So here parallel sides of a trapezium. Here ratio is 5:3. 5:3 means here parallel sides are here A is equal to, we write 5x, B equal to 3x. These two are the parallel sides of a trapezium. Now here the distance between these two sides, here the distance between them 16 centimeters is 16 centimeters. So we write that one. Here distance between the parallel sides, h is equal to 16 centimeters. Now we write the area of a trapezium formula. Area of a trapezium. Here area of a trapezium is equal to 1/2 into h into a plus b. Here a is equal to 5x, b equal to 3x, h equal to 16 centimeters. So these values substitute here. 1/2, here h equal to 16, a equal to 5x plus here b equal to 3x, that equal to here 2 1s are 2 8s are 8 into 5x plus 2x equal to into 8x. So here this is equal to 64x. This is the area of trapezium, 64x. Here centimeters, 64x square centimeters is the units. So this is the area of a trapezium. In our question here, the area of a trapezium is 960. So here according to the problem, here area is area of a trapezium. Area of a trapezium is equal to 960 square meters. So these two are equal. So therefore 64x equal to 960. X equal to, we write 960 by 64. So 8 8 are 64, 8 1s are 8 2s are. So again we take 8 table, 8 1s are 8, 8 5s are 40. So that equal to 15. Here x equal to 15. Therefore x equal to 15. So this 15, here we substitute the parallel sides of A and B. Here we know substitute these two values. Here parallel sides are coming. So now here parallel sides are, A is equal to 5x. Here substitute the x value, 5 into 15. 5 into 15. 5 into 15 equal to 75 centimeters. Next, B equal to here 3x. 3 into 15 is equal to 45 centimeters. These two are the parallel sides. 75 and 45 are the parallel sides of this trapezium. This is the sixth one complete answer. Next, seventh question. The floor of a building consists of around 3,000 tiles which are rhombus shaped, and each of its diagonals are 45 centimeters and 30 centimeters in length. Find the total cost of flooring if each tile cost 20 rupees per meter square. So here total building consists of around 3,000 tiles are there. Here total 3,000 tiles. The tiles are rhombus shaped, and each here diagonals are given 45 into 30. So here this rhombus, one tile is rhombus shape. So this rhombus area is equal to here 1/2 diagonals d1 into d2. First we find this one tile area. Next, find the total cost of flooring if each tile cost 20 rupees. So here we find the rhombus area, multiply here rhombus area, we find rhombus area multiply with total tiles. So total area is coming. So that total area multiply with 20. The floor of building consists of around 3,000 tiles. Here total tiles equal to this complete area, total tiles is equal to 3,000. rhombus shaped and each of its diagonals are 45 and 30. So now here diagonals of a tile are here D1 equal to 45 and D2 equal to 30 centimeters. These two are the diagonals of a tile. So now here we find the area of a tile. Here area of each tile. So each tile area is equal to here. This is the tile is the rhombus. So this is the tile shape is rhombus shape. So area of a rhombus equal to 1 by 2 D1 D2. This is the area of a rhombus formula. So here substitute these D1 D2 values here. 1 by 2 here 45 into here D2 equal to 30. 2 ones are 2 15s are. So here 45 into 15 equal to 675 square here centimeters is the unit, square centimeters. This is the one tile. Area of a one tile is equal to 675 square meters. Now here total here 3000 tiles are there. So here area of a floor, we find the area of a floor. Here area of a floor, here area of a floor equal to total tiles into here each tile area. Here multiply these two numbers. Here multiply these two numbers 202500 square meters. So here square centimeters. Here 202500 square centimeters, because here diagonals are given in centimeters. So this units is centimeters. But here if each tile cost rupees 20 rupees per meter square is given. So that's why here the centimeter is converted into here meters. 1 square meter is equal to here 10,000 square centimeters. So here we substitute here centimeters are there. So that's why here 1 square centimeter equal to, we write 1 by 10,000 square meters. So we write this one, this equal to, we write this one here 202500 here square centimeters equal to here 1 by 10,000 square meters. Now here centimeters is converted into meters. So these three zeros get cancelled. 2025 by 10 square meters. Here 202.5 square meters. So this is the area of a floor. So this area is converted into meters. So now here we find the, calculate the cost. So the cost of tile per square meter, the cost of tile per square meter, here rupees 20 rupees per meter square. So here that equal to rupee symbol 20 rupees. Now here the cost of the, therefore the cost of flooring, the cost of the flooring is equal to here 202.5 square meters into here 20 rupees. So here rupee symbol, we write rupee symbol. Now multiply these two. Here one digit before point is there, here 1 0 is there. So that two are cancelled. Next 2 multiply with this number. So that equal to 4050 is the total cost of the floor. So this is the complete 7th one answer. Next 8th question. There is a pentagonal shaped parts as shown in figure. For finding its area, Jyoti and Rashida so divided it into two different ways. Find the area in both ways and what do you observe? Here one pentagonal shape, measurements here 15 centimeters, 30 centimeters, 15 centimeters. These two are equal. So here both are, we find different ways. Here first Jyoti diagram, we draw the one vertical line divided two parts. So Rashida is draw the one horizontal line and divided two parts, one square, one triangle. So both are find the areas. So finally these two here find the areas in both ways. Here find the areas in both ways and what do you observe? So first we find this method and this method, Jyoti and Rashida diagram. We use these two and find these two methods, we find the area and draw the diagram here. So we use the Jyoti method. Jyoti method we divided to equal parts. So now here we find these two parts. Here we find these two parts area. Now here to here 30 meters means here this line is the 30. So here A, B, C, D, E, F. So F to C is the 30 meters, 30 centimeters. So 30 centimeters. So here distance A to E is 15. This total distance is 15 centimeters. So here 15 centimeters means is divided equal parts. Here to here 7.5, here to here 7.5. Here this is the, so here these two distance are equal, here these two are equal. So AB and FC are parallel lines, here middle distance is there. So these two, this is the trapezium AFCB. First we find the AFCB trapezium area. Next we find this area, add these two areas. So total pentagon area of a pentagon. Here area of a pentagon ABCDE is equal to, here we write here area of is a trapezium ABCF plus area of a trapezium CDEF. So we find these two areas. Here 1 by 2, here height. Here height is the AF. This one height is AF. So AF into, here parallel sides are AB and FC. AB plus FC. Here next one area of a CDEF. Here 1 by 2. Here height is the EF into, here parallel sides of CF and DE. CF plus DE. These two are the parallel sides. So now here we substitute these values. Here 1 by 2. AF is 7.5 into, here AB. AB is equal to 15 plus FC equal to 30 plus 1 by 2. EF equal to 7.5 into, here CF. Where is CF? 30. DE 15. 30 plus 15. So now here 1 by 2 into 7.5, here 45 plus 1 by 2 into 7.5, 45. Now these two are same, these two are same. So here 2 into 1 by 2 into 7.5 into 45. So 2 get cancelled. Here 7.5 into 45. Multiply these two numbers. Here 33750 square centimeters. So this is the final trapezium area Jyoti method. Jyoti, we use the Jyoti diagram. We find the area of a complete pentagon. Yeah, area of a pentagon ABCDE area. Now next we use the Rashida method. Find the area of a pentagon. Next here we draw the Rashida diagram. So this diagram, now here we find this triangle area and square area. Both areas we find separately. Next add these two areas, that complete pentagon area. So here we draw the perpendicular line. So here 15A, E is 15 means here also 15 centimeters. So next here to here 30 means here 15, E to D 15, here 13. 30 minus 15 means here 15 centimeters. Here F to C is 15 centimeters. So now we find the areas. Here the area of a pentagon. Area of a pentagon. Here area of a pentagon is equal to here area of a square. Here square ABDE. plus area of a triangle BCD. BCD. Now we find these two areas. Here area of a square is equal to here side into side. Here one side is 15. 15 into 15 plus here area of a BC into BCD is equal to here we write 1 by 2 into here BD into CF. So here 15s are here 225 plus 1 by 2 into here BD is equal to 15 into CF equal to 15. So now here 225 plus here 15 are 225 by 2. Now do the LCM. Here do the LCM means here 2 into 225. Here 450 plus 225. Add these two numbers 675 by 2. So here 675 is divided with 2. So 337.5. So that equal to here 337.5. So here we write here 337.50 square centimeters. This is the area. Now here we observe these two areas. Here first area is here 337.50 square meters. Here also same. So these two are equal. So we find any method that complete area is equal to equal. So we write the conclusion. The area of polygon cannot change if its proceeds are changed. These two procedures are changed, but final area does not change. So this is the 8th question. This is the complete 8th answer. This is the last problem of this exercise. So complete this exercise. This complete notes PDF link on description is there. If you are interested, download it.